Hi, I'm Navya. So I chose the topic of Boston housing. Um, okay, so the data set had a total of 506 cases with 13 attributes, and these are some of the features in the data set. So the ML algorithm that I used was linear regression, since it's a very simple one to showcase the linear relationships that were in the data set. Uh, The X and Y terms, the independent variables refer to the features which we've seen previously, and the dependent variable, the main target variable is the median value of homes, like the housing prices in Boston, which made it easier for linear regression. And so what I first did is I cleaned the data set, I found the missing values, replaced them with the mean, and then to test the data set, I split it into two, training and testing. And so before that, I did a correlation analysis. So as red refers to like the most positive, and blue tends to the more negative one. So to identify the most significant features in the data set, I got the strong positive ones were the average number of rooms per house. So the more number of rooms in a house tend to have a higher housing price. And also the houses that are closer to the highways also have a higher property tax rate. And the negative correlations that I found were the highest polluted areas also were correlated to the distance to the employment center. And so the houses that were farther away from the employment centers have a less pollution rate. And also the houses with the higher percentage of lower status population had lower median value homes. Um, so I drew the linear regression graphs between the actual values and the predicted values. And the majority of the points lie on the line, but there are a few away, which is shows that there is room for improvement. I calculated the mean absolute error and I got a score of 3.2 and an R square score of 0.66, and 66% means that it could do better because it couldn't showcase the non-linear relationships in the graph sense of the because of the complex patterns in the data set. And some uses of the outcome could be to prediction for living, finding a place to live, and for urban planning, policy making, checking the factors about pollution and so on, and also for realtors, investors to find out the if prices of the houses are either underpriced or overvalued.
So what is the conclusion and unexpected result that was surprising?
So I got a really low, like, I mean, not that low, but a little above average of 66%, which means there were little complex patterns that it could have identified.
What is the meaning of 66%?
So it shows how well the model explained the data, right? So that means like there are certain complexes. So maybe if we use like decision trees also, we could have identified the features even well. And here, like the mean absolute error of 3.2 means that the predicted value was off by 3.2 units from the actual prices.
And go back to that slide over about vicinity to employment center. What is that?
Oh, yeah, the
Can you repeat that again?
The NOx stands for the nitric oxide concentration, and DIS means the weighted distance to the employment center. So that has the strongest negative correlation, which means that the
Closer you are to the centers, the prices go low. That's what you mean.
yeah,
Okay. And what are the highly correlated
the
number of
positive ones, the more number of rooms in a house have the highest value of
accessibility to highways?
yeah,
That's also. Okay.
the highest property.
Thank you.
Thank you.